question is a second order active filter known as Butterworth filter is shown in the figure below. Okay, if we apply KCL V0 at VA, then we will get the two equations. If we solve, we will get the transfer function for this network, that is output voltage by input voltage as 1 by 1 plus SCR whole square. Then find what kind of filtering action it is performing. See, in order to check the what kind of filter it is, we need to take two conditions, boundary conditions, that is S equals to 0, that means omega equals to 0, S equals to infinity, that is J equals to, that is here omega equals to 0, omega equals to infinity. That means we are checking the two extremes, either at low frequency, that means 0 frequency, either we are checking at the higher frequency. See, if we substitute these values, that means S equals to 0, we will get output V0 by Vi as equals to 1, whereas at S tends to infinity, the output V0 by Vi equals to 0, means it is performing a low pass filtering action, that is option A is correct. Is the phase crossover frequency associated with a feedback loop employing a proportional controller, the process represented by a transfer function Gp of S equals to 2 e power minus S by tau S plus 1 whole square is found to be 0.6 radians per minute. Find the time constant is. Here, see, if we comes to options, A is 1.14, B 1.92, C 3.23, D 5.39. See, phase crossover frequency is nothing but a frequency where a phase function of a given network attains pi radians, that is minus 180 degrees, that is minus pi is equals to the phase function is minus omega 2 tan inverse of 0.6 tau. Okay, everything is given in the form of radians, so it's not a problem at all, because it is also in radians. While you are calculating in the calc, please keep it in radians mode, then type it. Here minus pi minus 0.6 minus 2 tan inverse 0.6 tau. So if we solve this equation, we will get tau as 5.39 seconds, which is option D is correct. The phase crossover frequency associated with the feedback loop employing a proportional controller to control the process represented by a transfer function Gp of S equals to 2 e power minus S by 1 plus tau S whole square is found to be 0.6 radians per minute. The time constant is given as 5.39 seconds. Find the gain of the proportional controller if the gain origin is 2. We know that 2k, that is the magnitude of GPS, k is the gain of the proportional controller, 5.39 omega p plus 1, this is whole square, equals to 0.5, because the gain origin is given 2, so it is equals to 0.5. Omega is nothing but phase crossover frequency, we substitute, so 2k is 0.5, 5.39 into 0.6 whole square plus 1. So if we solve this equation, we will get k as 2.87, which is option B is correct. Is a divide by n counter is designed using JK flip-flop as shown in the figure. The value of n is, if we see the configuration, this is the twisted ring counter or the Johnson's counter. If the counter is having n flip-flops, it is going to have 2 n states. So according to this statement, answer is here, it is having 3 flip-flops, so it is having 2 into 3, that is 6 states, that is option C is correct. Question is, a divide by n counter is designed using ZK flip-flops as shown in the figure. Assume initial outputs of all the flip-flops are 0. The output of the above counter is given to the circuit shown below, which consists of 3 line to 8 line decoder and LEDs. So the LEDs that will never glow are here. This is the twisted or Johnson's counter. So it is having a 3 flip-flops, means it having a 6 states, means out of the 8 states it's going to have a 6 states, means 2 states are unused states, means the ABC will never get those values as outputs. So if we give that to 3 to 8 line decoder, there are 2 lines are not going to be activated, means that means the inward means the bubble indicates 1. In normal position, O0 is having 1. So if suppose if I am giving 0 0 1 here, so O1 initially it is 1. If it is I am giving the 0 0 1 as an input to the 3 to 8 leak, O1 is selected, means that means the output at this position is 0. 0 means here is 5 volts, this 0, so the diode is going to be in conducting mode. Means here two lines are not going to be selected for any of the input combination, because ABC will not take two unused states. If we do the procedure or analysis what states is having, then we are going to know that D2 and D5 will never glow. Option C is correct.